So you're suggesting that we move that 6y over, and I think that's a great plan. So we have x plus 3y equals 8, and 2x plus 6y equals 16. Now we're eliminating. So we probably will multiply the top row by -2. So -2x, -6y, -16. When we add, we're eliminating those x's. Right? What else? Aren't the y's gone too? And aren't those gone too? So this one says 0 equals 0. Now that is very different than what happened down there. What happened down there was 8 equals 3 or something like that.
All real numbers.
Yeah, 8 equals 3 was nothing. But 0 equals 0 is, okay, now be careful. We're not going to say all real numbers. What we mean is these guys are the same line. So we can either say infinitely many solutions, or we can say they are the same line. If we graphed these two, like if I did this one with a blue pencil and this one with a green pencil, they would be right on top of each other. Down there it was different. Green and blue were parallel to each other. Here they are right on top of each other. So they cross in infinitely many places. What?
Did I say solutions?
It's solutions, yeah. Infinitely many solutions. All right. So, one more time. The quiz that we have tomorrow is going to be 2 problems. One of them is going to say solve using substitution, and the other one is going to say solve using elimination. Okay? That is old stuff. It's on I-STEP. You've all done it before when you were freshmen and again when you were juniors. You got it. It's easy. If you're having a hard time, get your book out, go to section 7.1 and work through some problems. Or redo these in the notes. But tomorrow you're going to have to substitute and you're going to have to eliminate. Now, they aren't the equations with the squares in them. They're just regular equations like this. Okay, but you're going to have to substitute one and eliminate one. Everybody clear on that? Okay, because now we're going to the next section of the chapter, where the real stuff begins. We're going to start talking about solving systems using matrices. Now, a matrix, you're on page 44, you're filling in your vocabulary. A matrix is a rectangular array of numbers arranged in rows and columns. If I were a betting person, I would bet that your test is going to ask you to define a matrix. A matrix, which is what this chapter is all about, is a rectangular array of numbers arranged in rows and columns. So, I have given you some. If you look down the page a little bit, here is matrix A. Oh. And here is matrix B. For example, they're written there on the page. Whenever you have a matrix, because it is a rectangle, it has dimensions, just like a regular rectangle does. It has like a length and a width, only we don't call it length and width, we call it rows by columns. So the dimensions of the matrix are the number of rows by the number of columns. And it has to be in that order. So I remember Roman Catholic, RC, rows by columns. Always rows first. So when I look at matrix A, the dimensions of matrix A, how many rows does it have? 2. How many columns does it have? 2. So it is called a 2 by 2. And we write it down there like that. Now, I don't want you to be confused by rows and columns. If you go to the bleachers, rows go like this, right? If you look at the White House, columns go like this. So rows of the bleacher, columns of the White House. Rows by columns. So what are the dimensions of B? How many rows? 2. How many rows? 2. How many columns? 3. So it is a 2 by 3. Rows by columns. Okay? Now, C is a square, that definition is square matrix. What do you think a square matrix is? Like a 2 by 2 or a 3 by 3. In other words, a square matrix has the same number of rows as columns. It's just like with a regular rectangle. What makes a rectangle a square? The length and the width are the same? The dimensions are the same? If the dimensions are the same, then it's a square matrix. And in matrix land, squares are the most special. We can do stuff with squares that we can't do with things that aren't square. So a square matrix is a matrix that has the same number of rows as columns. Same number of rows as columns. So, is A square? Yeah. Is B square? No. Square matrix, same number of rows as columns. Definition D, entry or element. Those words are used interchangeably. The entries or elements are just the numbers inside the matrix. So we can call them entries or we can call them elements, but they are the individual numbers inside the matrix. When we talk about them, if they are in matrix A, we'll use a lowercase a to identify that. That means I'm looking inside matrix A or I'm looking inside matrix B. If I wanted to talk to you about this number right here, I would use an A, a lowercase a, because that number's inside matrix A. And then I would put a subscript on it that was 2-1. That 2-1 stands for row 2, first column. Remember, when I identify things, it's always RC, Roman Catholic row column. So when I put a 2-1 here, I mean look in the second row and the first column, and that would be that number 3. What would B sub, let's say 1-3 be? What would that be?
3.
That's also a 3, because that means I'm in matrix B, first row, third column. So that's right there. Right? All right, a scalar. Scalar, those of you in physics have heard that word. Scalar is just a real number. You guys in physics might have called it a magnitude. It's just a real number. So The study of matrices and vectors have their own vocabulary, so they're not going to say number, they're not going to say coefficient, they're going to say scalar. So if you're talking about, if I want to take 2 times the matrix A, that 2 is called a scalar. It's called a scalar. And the last definition, equal matrices. Anybody want to take a wild guess what equal matrices are? What'd you say? Okay, yeah, how are we going to define that? Equal matrices.
When there's the same number in a row and column.
Okay, so we got to be careful. So, like if we had 1, 2, 3, 4, and then if we had 1, 2, 3, 4, 5, 6, are those 2 matrices equal? They have the same numbers in the same spots. What's wrong with them?
They have 5 or 6.
They're not the same size.
Different
So to be
dimensions.
equal matrices,
Same dimensions.
exactly, they have to be the same dimensions and the same corresponding entries. And what we mean by that is the same numbers in the same spots. So they have to be the same size and they have to have the same numbers in the same spots. All right?
So it means they have to literally be like exactly the same.
Exactly the same. They gotta have the same numbers in the same spots. So first row, first column, first row, second column, everything's gotta match up if they're going to be equal.
Is C still a 2 by 2?
C is 2 by 2. 2 rows, 2
Then
columns.
why does it say C3?
Yeah, we're not there yet. Kennedy. No. That's like having your phone out. And you know what happens when we do that. All right, dimensions of A and the dimensions of B. We're on part 1 now. We're done with the definitions. Here we go. Evan, they are distracting enough. You do not need to get involved in it. A, what are the dimensions of the matrix A?
2 by 2.
2 by 2. And when we write that down, we write 2 by 2. What are the dimensions of matrix B?
2 by 3.
2 by 3, and we write it like this, rows by columns, 2 by 3. What is the entry that's in the 2, 1 spot in matrix A? 3. What is the entry that's in the 1, 2 spot?
0.
0. What's the entry in matrix C that's in the 3, 1 spot? There isn't one. That's a trick question, because what do we not have? We don't have a third row. You don't have a third row, you can't have a 3, 1 entry, so there isn't one.
Well, we write
See
the
no
solution.
No solution. In matrix land, there are going to be a lot of things you can't do because the rules are very specific. So one of the things we can't do is add these 2 matrices together. It is not possible to add these together. So the answer to question C is no solution. No solution. Right, you can write no solution, you can use this empty set symbol, you can write can't do, somehow indicate it's impossible. Why is it impossible to add these matrices? They're not the same size. They're not the same size. In order to add matrices, you have to have the same dimensions. These do not match, therefore they are not addable. Now, can I add A and C?
Yes.
And the answer, I bet you can even guess it, is so easy. To add A and C, we just add the corresponding entries. So we add 1 and -1, 2 and 1, see what I'm doing? 3 and 4, and -4 and 0. So there's the answer. You add the numbers that are in the same spots. Easy peasy. E says 2A. Now, 2A, 2 is called a scalar, so we're taking the number 2 times the matrix A. Take a wild guess. It's as easy as you think it is. Take everything times 2. It's like distributive. So it's going to be 2, 4, 6, negative 8. That's it. That's it. 2C minus A. All right, now wait a minute. I need to do 2C first. What will 2C be? Negative 2, 2, 8, and 0. Everybody okay with that? That's 2C. Now I'm going to subtract A. Now, first of all, can I even do that?
Yes.
Yes, because these guys are the same size, right? I can't add or subtract unless they're the same size, but these are the same size, so now I'm going to subtract. So negative 2 minus 1. Negative 3.
0.
2 minus 2. 8 minus 3. 0 minus negative 4. There you go. Everybody okay with that? All right, now we got B minus 2A. What do you think about B minus 2A?
Can't do it.
Can't do it, guys. How big is B? This is a 2 by 3. How big is A? A 2 by 2. You cannot add or subtract unless they are the same size. They're not. So you can't do it. All right, everybody clear on that? Because the next page is multiplication and the rules are different for multiplication. So let's see how this
Are we
works.
still using the same ones from separate and
No, we got, oh yeah, I guess we are. Yep, I guess we are. Okay, so here we go. So matrix A is 1, 2, 3, negative 4. There's A. And I am going to multiply that times F. So this is A, and this is F. Everybody okay with that? I'm going to multiply them. Now, here are the rules, or here is the rule for multiplication. Write down the dimensions of each one. So what are the dimensions of this guy? 2 by 2. And what are the dimensions of this guy? 2 by 2. In order to multiply them, guys, these two have to match. So if you had a 5 by 8 and an 8 by 2, you can multiply. As long as these two match. So if you had a 3 by 2 and a 3 by 2, they're the same size, but they don't multiply. You gotta have the inside dimensions matching. The outside dimensions tell you how big your answer is. So in this case, my answer would be a 5 by 2. In this case, my answer is just going to be another 2 by 2. So these two match. These give you your answer. So my answer is going to be another 2 by 2. So 2 rows, 2 columns.
So if you like, so now you maybe you put it as an example, so your next one would be an 8 by 8, is what that would be? Or no?
No, your answer is going to be 5 by 2.
Oh, okay, yeah.
The middle two match. This gives you the answer. It's 5 by 2. Now, it's a little tricky. Pay attention. It's not hard, but you got to be organized. This number right here, to find that number is in the first row, first column spot. Would you agree with me? First row, first column. So we are going to multiply the first row times the first column. To get this number, we're going to use the first row and the first column. We will multiply this times this, and this times this, and add that up. So first times first, so 1 times -1, plus 2 times 3. So sometimes when kids are just starting, I say write down the numbers in your row, 1 and 2, and then write down your numbers in your column, and put a plus between them. That's how you do it. So -1 plus 6 is 5. So this number is a 5. Now, I gotta find this number. Well, I won't watch. What row is he in? First row. What column is he in? Second. So I am still going to use my first row, my 1 and my 2, but now I'm going to use my second column, which is 5 and 0. So I'm taking my first row times my first column. First row times first column. So that is going to be another 5. Coincidence? No significance, just coincidence. Okay. Now tell me about this spot. What spot is this? Second row, first column. So I'm going to take my second row, which is 3 -4, and I'm multiplying it by my first column, which is -1, 3. See what I'm doing? I'm going to add those. So what is that number going to be? -15. What's this? That's the 2, 2 spot. The second row, so 3 -4. And the second column, 5, 0. And that one is +15. And that's the answer to the question. Lordy, lordy, lordy. All kinds of room for mistakes in that one. All right, now we're doing F, bless you, times A. All right, so the next problem says we're going to multiply F times A. So matrix F times matrix A. Now, first thing you always do is check to make sure you're allowed to multiply. This is a 2 by 2, this is a 2 by 2. What's our rule? These gotta match. They do. So then these are the answer. So it's got to be another 2 by 2. Alright, let's see if we can fill in all those spots. Remember, you always multiply row numbers times column numbers. So row is negative 1, 5. Column is 1, 3. So what's that first entry going to be? 14? Okay. Now, Jalen, I need you to stop, okay? Stop. Malcolm needs to pay attention. He's going to focus. Chandra's not going to turn around. We're all going to be focused. Now, what spot is this? Row 1, column 2. So now I'm going to multiply my row 1 numbers times my column 2 numbers. So that's going to add up to be negative 22. Now this is the next one I'm after. This is in row 2, column 1. So I'm going to take row 2. So my row 2 numbers are 3 and 0 times my column 1 numbers, which are 1 and 3. And that'll be 3. And then last but not least, row 2, column 2, and that is going to be 6. Now notice that in the first example we did, we multiplied A times F, and then over here I just multiplied the same 2, but I did F times A. Did I get the same answer? No. So it matters. You want to make sure when you write your matrices down, you're writing them down in the right order. If it says A times F, it's A, F. All right? Next we have DE. Not possible. Can somebody explain why he says it is not possible to multiply D times E? D is a 2 by 2. E is a what? 3 by 3. They don't have to be the same, guys. That's not the rule. The rule for multiplication is these have to match. They don't. So therefore, it's not possible. You cannot multiply D times E. Got it? Now what about D times G? Now D times G, they are not the same size. What are the dimensions of D?
2 by 2.
D is a 2 by 2. What are the dimensions of G? A 2 by 3. They're not the same, but the important thing is those match. So the dimensions of the answer, it'll be over when it's over. You don't have to watch the clock. The dimensions of the answer are 2 by 3. Remember, these have to match, and then this tells me my answer. 2 by 3? Does Okay, so 2 rows, 3 columns. Now, I'm going to do the first one together, and then I want to see how many you can fill in, because I notice the period's almost over. So this is the 1, 1 spot. So we're going to multiply row 1 times column 1. So that first spot right there, the 1, 1 spot, is -2. Now, see if you can fill in the rest of these spots. This is the 1, 2, the 1, 3, the 2, 1, 2, 2, and 2, 3. See if you can fill in those spots by multiplying the row times the column. The row times the column. Now, it is so easy to make mistakes on this. So I need to make sure I did that right. So we need to talk about any of them that I don't match on. I'm missing Francie. Wait. I'm missing Francie.
Mason.
Daniel. Pruitt. All right, is that it?
Yes,
All right, you're out of here. Have a great day. Tomorrow we have a quiz. No, what is the quiz over? A substitution problem and an elimination problem. We have flex in the afternoon today. You can come, I'm going to help everybody that's here in flex. So if you have questions about review, yes, we can go over that. But I am focusing on the new material if there are kids.